Hi, everyone. Okay, today's just a quick video. This is to explain what we did yesterday because a lot of people were confused. They were able, let me go to Italy here. They were able to do the assignment. They just didn't understand the assignment. So I want to try to explain what it was that you were doing. And by doing that, I'm going to first go to the graphs. So we were talking about spikes in the grass, and it's very obvious when the spikes occur. And these two graphs kind of drilled down to what happened in the fall. So the beginning of September to the end of October. So kind of like it was focusing in on this spike right here. And in this case, again, this spike that happens right here. So we're just comparing just that subset of data. And the thing is saying basically what it is data analysts, what they do is they're always trying to analyze data and make trends and try to figure out what the trends are. And they use mathematics to do that. So if you were a data analyst, one of your goals with this COVID data would be to try to predict what could be the trend or what would be the mathematical rule or equation that could help predict if a spike was starting to occur. Because if we can realize that it's starting, like, whoa, we're headed in a bad direction, then you can let the Department of Health know. You could call up Governor Cuomo. You could call up the world leaders and say, hey, my analysis is showing that we're going in the wrong direction and we're heading up towards a spike. So we might want to do some things like start closing things back down, start putting masks on, whatever it is. But it's kind of like foreshadowing and pre-warning. The only thing is the only way to kind of work with a spike is to already have it happen. So we already needed the data to have occurred for us to practice with it and work on it to see if we could come up with a rule that would help predict that a spike was happening. We don't know what the rule is until we create it. So when we went to Italy, we were just looking from November 15th to October 20th, 2020, just that subset of data. And what we do know is this pink line was drawn in here because we know this is when the spike started. This was the beginning of the spike, and then we had this upward trend in Italy. Same thing with the UK. We had started here, and then we had this upward trend. So going back to Italy, what was happening was we calculated the percent change based on a day, 3 days, and 7 days. And if it's easier for you to look at, you can highlight this data. You can even come over here if you did a couple other ones and just turn it into a percentage. So if you don't like looking at it as a decimal, you can look at it as a percentage. And if you like that better, that can help you. So the first rule that we were testing is saying, hey, is it a positive percent change after every day? If we do it every day kind of percent change check and it's positive, does that predict the trend? So with the data that we already know that already existed, we know there was no spike here, but starting on October 6th, the spike began and all the way through here. So this is what we know happened. So we're trying to come up with a rule that matches this, that matches the no's here and the yeses here. That's what we're testing out. And then we're looking to see how well is our rule predicting it. Is it something that we should call Andy Cuomo on? Say, hey, Governor, how's it going? Helping you out here. I can see we're on a upward spike. So the first rule we tested was let's do a 1 day percent change. And let's see what happens when that 1 day is greater than 0. Does that help? In other words, a positive percent change. So if you notice initially it was 18.14%, 9.02%, 20.47%. Then we go down 14%, down 3%, down 14%, back up again, 3%, 17%, 8%, and so on. So this rule here, the rule that we put in was, hey, flag it when my 1% change is positive, my 1 day percent change is positive. That's what these yeses came up as. That's when they were positive. And if you look here, yes, and you look over here, you'll see it's a positive number. If it's blank and you look over here, you'll see it's the negative number, right? Then we compared our yeses to the goal that we wanted. Notice in this section, we wanted all no's, but we got a bunch of yeses. In this section, we want yeses. Well, we got a bunch of yeses there. But because of all of this up here, it's not really telling us that there is a spike. If we follow rule 1, we would have warned people on the 17th, 18th, and 19th, hey, a spike is coming, spike is coming. Oops, psych. Just kidding. It's going back down again. Didn't mean that. Oh, wait, a spike's coming, a spike's coming, a spike's coming. Up, psych. Just kidding. Went away again. So it's like giving us false readings, false statements. So that wasn't a really good rule. That didn't really work out so well. So it's like, get rid of that one. Okay, then we tried rule 2 based on a 3-day percent average, 3 to 8% change. And with rule 2, so here we had it all this, we put in our formula, and now we said, all right, flag it, not if it's positive, but if it's greater than 3%. Let's flag it if it's greater than 3%. So we did. Is this column, when it's greater than 3%, flag it. And let's compare it to our goal. Again, remember, we want this section to be all no's. See all the yeses? Giving us false readings again. We got some yeses down here, which is great, but we need this section to be more no's and this section more yeses. So rule 2 didn't look like it worked out either. Cross it off. Okay, then we did rule 3. And rule 3 involved a 7-day average, and it was saying, hey, flag it. Tell me yes when this column is positive and this column is positive. Let's see if that would work. And when we went through it, we got fewer yeses in this column. And the yeses down here kind of worked. But still, this is still a lot of yeses where it should be no's. I'm still not calling on anybody and saying, hey, I figured it out. I have the mathematical equation. So we don't know what it is. We're just trying to, like any other analyst, just trying to run some numbers and saying, hey, maybe this would be a predictor. Maybe that'll be a predictor. So it's the same thing like when we have a snowstorm coming in and the weather channels, they have different models. And I know like News Channel 13 always shows 3 different models. And they'll say this model is predicting, let's say model A is predicting we're going to get 10 inches. Model B is predicting we're going to get 11 inches. Model C is predicting we're only going to get 2 inches. All right. One of those models is going to be more accurate than the other. Sometimes those models all predict around the same value. Sometimes they're drastically different. I noticed it was a European model that was very well tended to do the best over the winter storms this past year. So whatever calculations that European model is using seems to be predicting things pretty well. So that's what we were doing yesterday, just trying to come up with equations that might predict a spike. Did we come up with a great one? No, not really. And in my class, one of my periods, we came up with a rule 4 where we were saying, all right, how about the 3-day average more than 10%? Just flag it if it's more than 10%. And even still, too many yeses. It was even worse than rule 3. So that was it. We don't know what the real rule is going to be yet. Hopefully this helped explain it. Have a good day and good luck with today's assignment. I will be on the Google Meet. Feel free to jump on in.